Hi to all. Today we are going to discuss classification of organic compounds on the basis of functional groups into homologous series. Yeah, we know that functional groups will play an important role for its chemical and physical properties of organic compounds. So here this classification of organic compounds mainly based on the functional group, then followed by aliphatic compounds, then we have aromatic compounds, then heterocyclic compounds, polymers, biomolecules, and others. Functional group, if we see the functional group, functional groups can have a decisive influence on a chemical and physical properties of organic compounds, and molecules are classified on the basis of their functional groups. So if you see here, so we are going to draw different compounds now. So for example, if we are going to see an alcohol, so alcohol will have an alkyl group, then followed by hydroxyl group. So hydroxyl group here, so it will stands for a functional group, so it will determines the physical and chemical properties of the group. So it can varies so by the attachment of alkyl group here. Then similarly, so if you see aldehyde, so aldehyde we have one carbonyl group here. Similarly for ketone, so we have two alkyl groups here that's going to attach to the carbonyl carbon. So these are the examples that we are going to see here. So in alcohol, if you see the functional group is nothing but hydroxide. So if you see the aldehyde, the functional group is nothing but aldehyde group. Then similarly ketone group as a CO. Then similarly for ester, so it will gives C double bond O, so CO. Then here is an ester. Then carboxylic group or COOH. So here we have different functional group that attaches to an alkyl group. It will determine its individuality. Okay. So now here, then apart from the functional group, we have another important classification in organic compounds. It is nothing but aliphatic compounds. Here aliphatic hydrocarbons are subdivided into three groups of homologous series according to their state of saturation as alkanes, in which the state of saturation is sp3 hybridized. Here the aliphatic hydrocarbon without any double or triple bond, so this means we are going to see a C single bond with the adjacent carbon, otherwise hydrogen atom. Similarly for alkenes, so we have alphenes. It is an aliphatic hydrocarbon which contain one or more double bonds. This means dialphenes, so it's said to be dienes or polyalphenes. Next important aliphatic compound is nothing but alkynes or acetylenes. So it is an aliphatic hydrocarbons which have one or more triple bonds. So both saturated alicyclic compounds and unsaturated compounds exist as cyclic derivatives. Okay, so we have a series of explanations for this. Then we seen the functional groups. Then apart from that, one of the important classification is nothing but Aromatic compounds. So aromatic hydrocarbons contain conjugated double bonds. So we have conjugated double bonds here. So if you see, for example, we have one benzene ring here. So this benzene ring will have alternate, conjugate double bonds. This means that every carbon atom in the ring is sp2 hybridized. If you see here, we are going to draw with the carbon skeleton. So if you see here, it will have totally 6 carbon atoms. So now these 6 carbon atoms is going to share a conjugate bond here. Okay, this means that every carbon atom in the ring is sp2 hybridized, allowing for stability. So that means if you are going to see the resonance structure, so resonance structure, we can draw the benzene ring like this, in which the electron density I am going to represent as a resonance structure. Otherwise, I can draw like a dotted lines that represent, these dotted lines can represent the electron cloud density is going to be rotated above and below the plane. How means here, if you are going to see the p orbitals here, then each and every carbon atom it's going to allow for sp2 hybridized with this p orbital. So this p orbital above and below the plane, we are going to see the molecular orbital. So due to its nature, so it is more feasible for organic reactions. The most important example we are going to explain now is nothing but a benzene. So this is going to formatted by the Keklu. It's going to follow the Haeckel's rule. So Keklu's first proposed the delocalization of our resonance principle for explaining its structure. Okay, now the important concept about heterocyclic compounds. So we are going to deal the separate subject for this heterocyclic chemistry also. Heterocyclic compounds. Okay, so these will possess an aromatic nucleus with heteroatom. So in which we are going to see the conjugate double bonds as that of the benzene. Okay, the characteristic of the cyclic hydrocarbon are again altered in heteroatoms, okay, which can exist as either a substituent attached externally to the ring, so exocyclic, or endocyclic. Okay, that means you are going to see the ring itself. In the case of the latter, the ring is termed as heterocycles. Pyridine, for example, now we are going to see the pyridine ring. Then and furan are examples of aromatic heterocyclics. So now we are going to draw the furan ring. So this furan ring will have the oxygen and alternate double bonds here. Okay, so similarly, if you are going to see the thiophene nucleus, so in place of oxygen, we are going to replace the sulfur atom, then followed by alternate double bonds. Okay, these are the examples of heterocyclic compounds. Okay, then now we are going to see the polymers. Polymers. One important property of carbon is that it readily forms a chain, that means a series of networks, okay, that are linked by carbon and carbon bonds, single bonds. The linking process is called the polymerization. Okay, so while the chains or networks are called polymers. The source of the compound, the individual source of the compound is termed as a monomer. So two main groups of polyesters, otherwise polymers, exist. So these are nothing but synthetic polymers, then biopolymers. Synthetic polymers are artificially manufactured and are commonly referred to as industrial polymers. For examples,